Hi, everyone. Today, August 7. Welcome, everyone, to this working group serving call. This meeting is being recorded, and we follow all CNCF protocols. Please behave and be nice with each other. Let's start by sharing the screen. Let's start with the workstream updates. So orchestration, Abdullah, you're first.
I can also talk about it. So basically, we have this proposed directory structure for the model serving catalog, and I think we want to move forward with it. And so I think it would be good to set up a deadline for community feedback, so that we can move forward after we reach the agreement. I don't see a lot of comments yet, so hopefully people will take some time to review.
Yeah, sorry, I was looking for the unmute button. I would like to suggest that we start with a really high-level structure and start iterating over it in code. I don't want us to continue to go back and forth on this without making progress. I think having a structure where we have, if you can you click on the proposed directory structure, please? It's really simple what we can start with, like something, for example, divided into core or whatever, like basic, and then other frameworks would be as top level directories or packages like kserve, etc. With core, we mean the most basic resources that you need to create and use to create a model service, whether it's like deployment service, and so forth. And then we can start with a couple of basically PRs there for popular models like Llama on VLLM, TGI, the most popular one, and we take it from there. Because I don't want to over-engineer and over-design a directory structure without making progress. I guess that's my hope here. Is not to dwell over this one for too long.
I have a question. Would it make sense to also, for models and for the serve, as it's called in kserve, they're serving runtime, right? Like, what if I want to run Llama on top of VLLM or on top of Triton, right? Like,
yeah. So we have, you see, so you want to run Triton, for example, where you want to run Triton under what, like using a deployment or using kserve. I think that is a clear distinction here, and that's why we have them as like top level structure. Like kserve is completely different, going to be the customizing everything and the commonalities between Triton, VLLM, or TGI under kserve versus under like a raw deployment, right? Even if you use the raw deployment mode in kserve, you still have to create an inference service, right? So your top level API is different. Does that make sense? Or does that answer your question?
yeah, thank you. Clayton, I think you're first.
I was going to say, I was thinking about like what I would want in the directories that isn't just the content, like a good README about describing what this is for. Mm-hmm. I think I'm okay with like merging and coming up with a structure, but like I think we should at the minimum have, when we land, a README under serving catalog that specifies intent and what the kind of rules of engagement with each directory are, just like a couple of basic ones. That would actually be, I think just having that would actually be, we've got the doc, we've had a good discussion. We can start iterating. We should make sure that's captured so that if we want to change stuff, that people who are reading the directory structure understand that they shouldn't just copy this and, like set the rules of engagement in the PR. And then I know you and I were chatting, I didn't have a chance to look at the PR recently, but like owners and like a substructure for like how we would kind of keep trying to evolve this. Like I assume we've said the end state of this is that we're trying to generate a representative example of both what you should do, as well as to highlight the points of variation and differences, I think we should very explicitly state those in the goals in the README, and then that kind of defines what changes might be valuable in the future as well. Like, are we committing as a project to supporting this? These are example only, and then at some point they shift to a different phase. We should make it clear expectations up front. That's what I consider minimum. I think that would be like a good minimum thing that then allows us to iterate in subsequent PRs and just changes to the repo.
I can submit a PR, like initial PR here, to basically create that like serving catalog directory with the README that basically tries to articulate the goals here, and potentially also discuss owners of this, who's going to be like the primary reviewer moving forward.
Yeah, and Jan's, like, I think there's a big discussion I want to have, which is Jan's comment about CI, sanity checking, EDE testing. I think that's a huge thing that we can provide as benefit. But like, even just at the minimum, having something that does like basic sanity checks would be a nice, always start with having some basic CI versus avoiding it until it becomes a pain later. So that would be maybe another, doesn't have to be when we merge, but I think I'd like to have that really soon as a follow-up.
Yeah, so I have so one question is regarding the CI. I think Clayton already covered that. And the other question I had is what's the definition of core, or do we want to call it something else like basics? And also like for Kserve directory, for these framework specific directories, do we want to follow the same folder structure as core, or do we want to make that independent and more flexible?
I think it depends on the, like, again, we're trying, we're going to set the goal, try to set the goals in the README. As Clayton mentioned, we're trying to basically define the points of variation across, like, different deployment patterns. And this is basically our guiding principle. I believe that, like, for example, if the points of variation going to be, what is the model, what is the model server, and what is the hardware? Those are like the minimum three that we can think of right now. And organizing them across those three dimensions, I think, makes sense across all frameworks. But again, it will depend on the framework, how those are being exposed, right?
Yeah, so the question comes, like, because there's no one-to-one mapping between different frameworks and the core ones. So for example, Kserve may have certain features that that you can't do in LoRA Kubernetes.
Yeah, I think we could leave them also to the, like, framework experts as well, to suggest something that aligns better with that API. So I'm open to that suggestion, like to that direction as well. What do you think?
Yeah, sounds good. We can probably start with the defining, make the core structure more well-defined. Maybe give the community, like, say, like, let's say we meet next week, and I think, assuming all comments are addressed, we can move forward. Does that sound good?
I don't know if we need to wait another week. Like, this, I mean, sure, we can like try to solicit feedback, but I think anybody who wanted to give feedback had access to this document for a couple of weeks already. If we agree that we need that README file that sets the, like, roles of engagement, defines the initial structure around, like, top level frameworks, which is vanilla, let's call it, Kserve. Those are basically the initial two. We will start with vanilla. Kserve is to be driven by Kserve experts, how you're going to structure it.
Okay.
And then start with the basic, like Llama, at least two, right? Like, so just to highlight some variation points. Llama on VLLM and TGI. I feel that I don't want to, again, continue to go back and forth without making progress. I feel that once we have something in code, it becomes more, or like, it becomes easier, right? Rather than discussing in comments and so forth. Especially that this is not an API, right? Like, we're not committing to something, like, that we can't change later on.
Yeah, that's fine. I totally understand. I think there's no blocking comments from me, so I'd love to hear feedback from others. So
Sound good. Thank you.
Thank you, John. Minaski, you're next.
Thank you. I just wanted to understand if I'm reading this right. So with the serving catalog, there are different platforms. One could be Kubernetes, the other could be K-serve as an inference platform. Is that how to read this? And then within upstream Kubernetes, for example, you can have different types of, let's say, backend or runtimes, which are like Jetstream, VLLM. And if you wanted to add, as Eduardo pointed out, let's say TRT LLM backend or something, we could add that as well. Is that how to look at extending the structure?
Yes, you're exactly right. We're like, and we're open to suggestions of how we structure it, like whether it's going to be, for example, the model is top level, and then under the model we have VLLM, Jetstream, the model servers, basically TensorRT, or the other way around. I think we will have some aspect of like, provider specific policies, because like, how would you, for example, say that I want H100, right? It's going to be slightly different between AWS, GKE, and Azure. And that's why I hope that we can also build like a command line tool on top of this that allows us to navigate this structure in an easier way.
Sounds good, because we did open source our operator, NIM operator, which allows you to do a standalone deployment with DRT, exactly what you have defined here in deployment. So this is good. Thank you.
I think NIM operator could be another top level one. Like there is the basic, we call it vanilla, which creates directly from customized a deployment, a service. It's like the really basic, like, resources that you usually use to deploy your web server, etc. And then there are the frameworks that tries to abstract some of these things and provide their own APIs to create a deployment in a service. Like K-serve is one. I think NIM operator is the same, right? Like, because you have a NIM service that after you create the NIM service CRD, it creates the deployment. It creates the actual deployment and replica set and so forth.
Yeah, sounds good. Thanks.
Thank you, Minaski, and thank you, Abdullah, for the explanation. And next is Andre.
Yeah, just maybe quickly. Thanks for this, Abdullah. So I'm just like a few questions. So the first one, I know we have like few images, right? We kind of like, providing by the community. So my question is like, I'm asking about like the images where we actually, build the model servers, right? So how are we going to maintain them, and where like the source code will be located for each model you want to like support, right?
So the weights like we can't host them anywhere because they have like rights around them, like llama weights. You have to I think we can describe those as well as points of variation, like from TGI, from Hugging Face directly, or if you've already downloaded it and you're looking it up from a PV. The container images, we can debate this. I think VLLM, TGI, TensorRT, they have public images already, and we can point to those. Jetstream will have those as well. The other thing is, I think here we can also have another like directory that describes how you can build them yourself and push them to your private repo. Either like point to where these Docker files exist, or actually us proposing some Docker files to build them.
Yeah, because
actually,
yeah.
I was going to add that point too, like the other discussion we're having around, is there better, are there things that we could do to improve image distribution of model servers plus model weights? I think that would dovetail. So like the same kinds of things that y'all are both describing here is we want to stay flexible to that. So identifying the problem and making it very obvious gives us the experience to say, here's some recommendations, be able to describe those, and then to identify gaps that we could go fill with better tooling, better ecosystem, working with various vendors to streamline that process for inference platform teams.
Yeah, because I guess my question is, like there are multiple like ways how people, you know, place their models on the control plane, right? You know, some people use model cars, right? Some people use PVCs, right? I'm just like wondering like how we're going to solve those problems, right, for different set of users, right?
That's discussed in the, I think that's a topic for the auto scaling work stream. We teed that up, but we did the first part of that discussion, but we haven't had the second part, which is I think what you're describing, the different ways of the different, how do we standardize, or what are the things that could be standardized? What are the options, and what are the trade-offs that could be better supported for actually loading model weights? We had the first part of that discussion, but we need to have more.
All right. Yeah, would love to hear this. And also, like the second question, like in terms of the supporting, you know, frameworks, right? And I can see like VLM just stream as initial, you know, support. So I guess like in the future, we're kind of like extending, you know, like when we decide which like, you know, lower level framework we want to like implement to give a user's ability to serve those models, right? Like, will it be up to the, you know, like underlying orchestration workload to decide which frameworks they're going to support, for example, like for Kserve, for LWS, right, for all deployments, or we want to like make unify them across all these, you know, like orchestration frameworks?
I think we're trying to expose the problems, and
Yeah.
us acting to try to provide something useful is as good a proxy as we can get to the pain that's just caused by having a relatively, like, I don't think we should accept the status quo. I think it's just trying to get us in a spot where through the actions we're taking, we're identifying these problems, coming up with recommendations, and you're working as a community to try to improve them where we can.
I'm moving on to the next work stream. That will be DRA.
Yeah, I will try to take a little bit of time. There is the main activity happening right now is 131 validation. Yesterday was a device management working group meeting, and was an example DRA plugin, and also Antonio presented DRA for network interfaces, which was very interesting. One of the scenarios there is ability to pick and express that you want the same network interface and GPU device with matching properties, meaning that somehow we can get them on the same PCI route. So many things like that is possible, and validation is happening. I think we need to start thinking what we want for 132. I think DRA device management group has their own wants, and we need to understand if we have any wants from workgroup serving.
Thank you. Any questions? Once, twice. Okay. So for the auto scaling meeting, the last week we had an interesting conversation, and I think this is attached with Clayton was saying, is the protocols standards, right? Like, should we stick with OCI image standard for pulling and pushing models, or should we embrace another standard like the Hugging Face standard protocol for pulling models, right? So the discussion kind of like circular around that, and we will have like a second round on this conversation during the next meeting. Ray, I see you here.
Yeah, I think that was exactly what I wanted to mention. Maybe we should like book a slot in this meeting, maybe next week, to discuss that just with the bigger group, because I think it is a pretty interesting topic. Someone mentioned that in the auto scaling meeting last week, so I wanted to make sure we covered that.
Perfect. Thank you, Ray. Multi-host.
Sorry, yes. They're not actually that different either, right? They are both at the end of the day SHA downloads, because Hugging Face uses Git LFS, right, which is basically HTTP with a SHA at the end of it, and Docker or whatever we're calling it today, image registries use the same thing, right? It's how you get those SHAs that's the only actual difference.
Yeah, Justin, I think that this would be a good thing to just suggest and try to get somebody interested and go play with it, because it is, we're doing a lot of like talking. I think like it would be actually awesome to, like, now that we have the serving repo, if you wanted to do a quick experiment and then, you know, go sort through some of those, I think like that's the phase we're in of how do we start tackling improving things.
Thank you. Multi-host, Jianxin.
Hey, yeah, last week we had the meeting talk about the network requirements on the multi-host like inference, right? We I think we got a few like feedbacks from the community. A lot of people left the message and also synced with me. I think one biggest challenge now is the I think people are already familiar with the TP and the PP inference, but the preview disaggregation one, I think in the community there's no public inference. There's no inference engines that have this feature supported. So yeah, I confirmed with the DServe authors. I think they are still busy with the PR, and they try to check in by end of August, and the VRM community is helping on this as well. And for the multi-host inference, I think I also talked with Abdullah on this, and leader workers that have a PR to support the Llama 3.1 larger models. And I know like Kubernetes community have the proposal to support the service as well. Yeah, so that's the kind of the two progress on different orchestrators to support the multi-host inference. Yeah.
Any questions on that?
I have a question. Sorry, I'm not very too familiar with multi-node. So would it also work with MPI, or would it only work with kubenet?
Yeah, that's a good question. It depends on the framework. Like VRM, the default runtime executor is Ray. So any orchestrator support Ray can run that VRM in distributed way. Like other like the Triton LLM, it use the MPI interface. So in that case, if we want to run Triton LLM in distributed way, we need MPI-based solutions. I think the leader workers that have most of the like the support, like the MPI array or native like Kubernetes-based, is supposed to be the like the orchestration for such frameworks. Yeah.
Thank you.
There's a question.
Rupo.
Yeah, I have a question. So you mentioned like some like this author, they will add a PR for the preview to the VM committee. So I saw one PR in the VM like GitHub repo. So is that the one that I linked on the right side? That they plan to merge that, or like they will add a new one?
Oh, that's different one. I think the Quintai is from University of Chicago, so that's a different proposal. I think these are users that right now is intern in he's doing the intern in Microsoft, so they will collaborate a separate PR. Yeah, that will be separate. Yeah.
Okay, sounds good. Thank you.
The PR 6170, that's a proposal for the KV cache transfer. That will be more on the KV external KV part. Yeah.
Okay, sounds good.
Jianxin, is there a link to the kubernetes proposal?
Not yet. That's under the discussion, but I think it will be available as an issue or a Google Doc. I think next week. Yeah.
Okay, thanks.
I'll share the link later.
Thank you. Clayton, do you want to share screen or take control?
Actually, I'm going to, Kellen's going to drive the demo, but I'll just do a quick voiceover. So I sent an email this morning. I teased this a few weeks ago, showed that diagram. We've been looking at, there's kind of, with LLM Gateway in general, there's a set of features that are kind of a high level routing set of features. And then we believe there's some opportunity for what are kind of a lower level set of features, which are scheduling decisions, scheduling requests to backends, where for standard load balancing, as requests come into backends, they're mostly, most requests have kind of an even weight. If you send it to one server versus another, it has the same impact. With LLM, that's a lot of LLM workloads, that's not true. And also, you might have heterogeneous hardware in a way that you really didn't have for web applications. A lot of Kubernetes over the years, we didn't define the type of CPU in Kubernetes because it didn't matter. Performance was roughly the same, and then people who needed specific CPUs or wanted to get a 10 or 15%, or maybe even in some cases 30% boost, would just run on a different type of node and use node labels to do that. So the observation has been that LLMs give us that opportunity to do non-uniform load balancing. And so we were hypothesizing there's this instance gateway. The use case that we were focused on actually was another key thing that Kubernetes offers and has since the beginning for microservices, and this is partially what enabled microservices to get so big, is that you've got these big Linux VMs or bare metal machines that have lots of CPUs, and Linux is really awesome at splitting up CPU among different users. And so you could run lots of different workloads, big ones, small ones alongside it, monitoring, and we saw the microservice explosion, and Kubernetes had great support for that. Now with LLMs, with large language models, there's no accelerator that is so big that it can run multiple very, very large models. In fact, it's almost the opposite. We're running multiple accelerators underneath single models. And so for teams that are growing the number of use cases that they're supporting, and a unique characteristic of LLMs is they can actually support multiple use cases. The big thing around ChatGPT that everyone discovered, which was you could go pitch a startup based on the idea that just by changing the system prompt, you can get different behavior since you're using natural language. And so prompt engineering and crafting a prompt for different use cases is a capability that LLMs have that previous stateful and stateless workloads didn't quite exploit. So with the idea of traffic scheduling plus LLMs can already support multiple use cases, plus the fact that it's hard to run, it's inefficient to run lots and lots and lots of different of the same model server for different use cases, we started exploring the idea of using LoRA to multiplex different use cases onto the same pool of model servers that are sharing the same base model. LoRA adapters are, allow you to bring fine tuning, so you can kind of avoid having to have different whole fine-tuned models and get some operational wins. You can also use prompts, but if you do that, if you're sharing all these workloads, you need some operational controls, which we're basically missing. And so this proposal is very gateway and Kubernetes centric, the idea that you can have multiple use cases to a shared pool of LLMs. You can do it mostly with load balancing. And if you do that, what would the actual design look like? And that's what the team we've been working with, Jiajin, on use cases. There's a lot of very high scale people doing LoRa adapters at scale today. And we've been trying to boil those down into a component that we think would be generally useful for many people running LLM self-hosted on Kubernetes. So with that, turn it over to Kellen to drive the demo and discussion of the POC. I kind of talked a little bit to Kellen's slides just to tee this up, but Kellen, please feel free to go ahead and repeat anything that I described poorly.
Sure, no problem. It was well done. Cool. Good morning, and thank you for joining us. As Clayton mentioned, a few of us at GKE and ByteDance wanted to take a look at what a gateway for multiplexing models might look like. As you mentioned, some of the problems with LLMs is the size. Makes for large startup time. That's similar. We have more use cases than we do accelerators that can handle them. If we want to swap those use cases, we incur that large startup time. All of that, kind of to Clayton's point, is time spent paying for an accelerator you might not be getting the full utilization out of, or if we can get more, why shouldn't we? So to kind of boil all of that down to a question, how can we run multiple tuned models for different use cases on our limited pool of accelerators? So how can we take our many use cases and put it on our limited resources. So to discuss that, Clayton mentioned LoRA. I want to dig into that a bit deeper. This isn't meant to be exhaustive. For anyone who doesn't know, LoRA is a parameter efficient fine-tuning method. So what that means is when you fine-tune your base model, you'll get a much smaller checkpoint. For our demo purposes, we used a rule of thumb of about 1%. We've seen larger, but we'll just assume 1% for now. With the base vanilla LoRA, you would merge that adapter into your base model. So you still have that one-to-one use case. But that changed with multi-LoRA, where they made some kernel adaptations and they extracted the adapter from the base model so you could store multiple separate adapters on your accelerator and heterogeneously batch across those, which gives you access to your multiple use cases on a single smaller base model. Again, as mentioned, some of the operational concerns were left as an exercise to the reader. So that is a lot of what we're going to focus on. To kind of continue the introduction, we'll zoom into multi-LoRA and how it's handled at the model server. We're going to look at adapter state. There's really only two states that we're concerned with here in this presentation. One is the GPU it's in the GPU, ready to serve, or it is in CPU memory, ready to be swapped in. Model server handles requests first come, first serve. So if the top of the queue has a request for an unloaded adapter, simply waits till an adapter is free, swaps in, and carries on. All of these properties do give each model server a unique state relative to the LoRa adapters and relative to its replicant siblings. So we decided to take a look at what we can do to maybe improve efficiency or operational concerns using these properties. The first thing we looked at was the LoRa-aware routing, or using the unique state of a replica to see if we can improve efficiency. So we created a router that was fed adapter data from the model server, and it would route based off that data, compared to a simple load balancer that would just round robin. So as you can see on the right here, we have a request for our foo adapter. It comes to our router and goes immediately to this LLM replica here that has foo loaded. So to describe our experiment that we did to verify this, we set 3 model servers, each allowing a maximum of 4 adapters per accelerator, and then 12 distinct LoRa adapters. With the idea being, if we were to route correctly, we would have 100% coverage of our use cases. We then sent 1,000 concurrent requests against our backend, and we looked at throughput compared to our control group. We were pretty happy with the results. We found our LoRa-aware routing could improve our efficiency by 85% over our standard load balancer, our control group. Big number. Question might be why or how. Where's the efficiency coming from? And hopefully the picture paints some picture, but we think it is due to a logjam that can come from first come, first serve. So for example, let's say you have a model server with open batch. The top of the queue is a request for an unloaded adapter. That request has to wait for an adapter to free up, as well as the rest of the queue, even if that queue contains requests for adapters that are currently loaded, that could, in theory, start right away. So again, a follow-up question might be, why not have the model server handle that? Why not adjust the model server to have different batching strategies? And it's a fair point, but we believe that the global context of a gateway allows for better informed decisions, both on fairness as well as routing and efficiency, because it's aware of the entire compute pool rather than relying on the context of self. So we took a look at fairness as well as one of our operational concerns we wanted to look at. The question we asked was, given 2 distinct use cases with different traffic patterns, could we enforce fairness on the KV cache? So we kind of went indirectly measuring the KV cache. Since this is using the same base model, we just measured total tokens, both input and output, and we tried to enforce on that, despite it being across different replicas. So we ran an experiment there, and again, we were happy with the results. We found that when we enforced fairness, despite traffic differences, we saw that the total token process was anywhere from 1.7 to 16%. And then when we didn't enforce fairness, we saw a much larger disparity where we saw anywhere from 53 to 62%. all while maintaining roughly equal throughput. We saw about a 3.5% difference, which I would argue is completely within margin for error. So with this strong foundation, we wanted to design, with ByteDance's help, an API that could handle both large cases like ByteDance or smaller cases like a startup. And to discuss the API a bit further, Rob Scott. Rob?
Yeah, thanks, Kellen. I spent a bunch of time thinking about what an API would look like here and where it fits into the Kubernetes ecosystem. And of course, I'm going to be biased here, but I'll go ahead and say that I think we've designed Gateway API to be modular enough that you could bring a custom route type into the existing ecosystem. So today we have routes like HTTP route, gRPC route, TLS route, etc. But what if we introduced some kind of higher level concept that was focused on LLM routing? So for example, we have an LLM route that we could add that had some higher level constructs. And I made a really rough sketch of the kinds of things we might want to represent in this API. But let's just imagine that we have the same base fundamentals that make a resource a gateway API route. You have a parent ref that points to gateways. You have so the infrastructure layer. You have backend refs that point to your services, but then beyond that, you have basically the routing characteristics. How should you select the backend? So in this case, maybe we're defining an adapter that has some level of prioritization. We want to define some objectives for that adapter, such as a output token latency that has a P99 value of 2 seconds. And then we want to be able to describe where we can get metrics for this adapter. So maybe a format and a location. Again, this is very high level. Don't over-index on this, but this is just an idea of how you could communicate some particularly helpful things using the route concept in Gateway API. But with that, we can move away from just something really abstract and actually look at how this could work in real life. So I'll hand it off to Kaushik for a demo.
Thanks, Rob. So based on the ideas we just discussed, we built a prototype. So here is the overall design. There are 3 essential elements to the design. There is the Envoy gateway. There are, of course, the backend model servers. Here I'm showing 3 replicas. Each has the LLM model loaded, as well as each has different set of LoRa adapters loaded in GPU memory. So the first one has adapter A, the second adapter A and B, and the third has adapter C in GPU. And the third is this new CRD we have built called LLM route, where the routing decision is being made. Behind the scenes, it has 2 key elements. It has XProc, which is an external processing gRPC server. It's a capability that Envoy provides us. We can extend Envoy for our custom use case. And there is a new resource. We have there's the HTTP route resource of the Envoy. So together they form the LLM route. So let me give you describe in some detail how the LLM route works. Next slide. Okay. So as I mentioned, it has this XProc, and in the XProc we collect metrics from the pods. We collect either from the response headers or by scraping metrics from the backend pods, from the /metrics endpoint of the model servers. And we store in its cache things like what are the different backend pods, what are the active adapters loaded in memory, and what are the number of pending requests for each adapters. This is just an example. We store more metrics. And based on these, this information, this data, we make the routing decision. To give you a more concrete example, can you go to the next slide? Yeah. So here I'm showing 2 LoRa specific use case. Okay. So there is this use case called coding SQL. So there's a LLM route called coding SQL, which corresponds to the LoRa adapter coding SQL, which I think is fine-tuned for SQL code generation. And there is tweet summary, which is a LoRa adapter fine-tuned for summarizing tweets, I think. So This is OpenAI protocol. The user is sending a curl command for the model, say coding SQL. The request goes to Envoy. The Envoy routes the request to the appropriate LLM route, in this case, coding SQL. And here is where the routing decision is being made. And then the request is routed to the appropriate pod. So this is how the request would flow. Next slide. Okay, so we have a demo here. So can you play the video?
Yeah, let me switch tabs. It wasn't working when I was testing it earlier. 1 second. Go.
Okay, so, all right. Yeah, can you play it? All right. So this is the backend.yaml. Here I am deploying 2 resources. I have the gateway and I have the model servers, in this case, 2 replicas of VLLM. And I have the backend service called VLLM server backend pool. Okay. And then I have the LLM route.yaml, where, as I mentioned, I have 2 LLM routes. One is called coding SQL, which corresponds to the LoRa adapter coding SQL. And the second is tweet summary, which corresponds to the LoRa adapter tweet summary. Both point to the same gateway that I deployed in the previous YAML and the same backend service. Okay, so these are the 2 YAMLs. So now let me deploy these resources. Okay, so, all right. Okay, these are already pre-deployed, but as you can see, I wanted to show you what are the resources we are deploying. We have the gateway, we have the VLLM, we have the backend service, and we have the 2 LLM routes, coding SQL and tweet summary. So now let's find the IP address of the gateway. Okay, so the gateway we deployed is GenAI Inference Gateway, and this is the IP address. So let's send a couple of curl commands. Okay, so this is the first request we are sending for the model tweet summary. And okay, so we had a prompt, we got a response. But the important thing to note here is we are printing a bunch of things in the response header. So the first thing to note is the target pod. This is the pod where the request was routed to. And the second thing to note is this thing called active LoRa adapters, which is the active, the GPU, the LoRa adapter loaded in memory for this pod. So the reason this request got routed to this pod is because it had that LoRa adapter loaded in memory. So now if I send the same command again, this request will always get routed to the same pod because it had that LoRa adapter loaded in memory. So yeah, so you will always see the request is getting routed to this pod ending with KDPTC. So now let me send you, let me send another request for a different LoRa adapter coding SQL. And okay, so now it got, the request got routed to a different pod where this particular LoRa adapter was loaded in memory. And again, if I send the same request again, the request will get routed to this different pod, which had that LoRa adapter. So this is just a demonstration of how it works, where, of course, the simplest case, we want to route it to a pod where it's loaded in memory, the corresponding adapter. So thank you.
Thank you all. That's our demo. Questions?
Cool. Yeah, looks good. So question is like, how do you, where do you maintain that, like, which LoRa adapter is stored on which pod, like where that information is stored?
It is in the XProc, the external processing gRPC server. So the request gets routed to this server, and that is where the information is stored.
It's stored in memory, like in the XProc?
Yes.
So how do you, if the pod restarted, like how do you like keep that updated?
So it gets the request from the backend pods. And in this POC, we are scraping this metrics every few seconds. So it's always fresh because there is some inconsistency, but not much. Yeah.
Yeah, and I want to emphasize one of the things we were discussing on this was there's the difference between like the theoretical hardware that you deploy. Like you deploy an H100, you expect it to have a certain latency profile, you put a certain model on there, you put a certain model server version, you have a certain amount of traffic, a certain input output link, and you get an outcome. And that's like a lot of people are predicting that today, and it's built layers on top of that. One of the things that we were thinking about is we think there's a need for the static configuration, someone planning out their deployment. But then we think the opportunity is actually when you mix things, you end up able to deliver better efficiency. And for that, you want to be somewhat more dynamic. So the POC is very much aimed at showing that dynamic aspect, which is rather than look at a pre-configured and say, this is what should be happening, you make a load balancing decision, you observe the load coming from the backends, and you build a model at the gateway layer that is resilient. For instance, let's say you roll out a new version of Triton and the performance jumps 10%, or performance falls 10%. If you just blindly load balance, you might have availability issues as the pool rolls out. Whereas if you kind of start from the assumption that you're observationally monitoring as things are happening, you can be a little bit more resilient to those. So that was kind of the framing that we were going down.
Sounds good.
Changing your question?
Not a question, but a comment. I think people may confuse about the configuration is the pre-assignment or dynamic load, etc. I think Clayton addressed part of it. So my comment is that this part actually in the downstream, I think we solve part of it. I think Clayton, maybe next time I think we can probably give more documentations on this. So like how inference engine work with the orchestration like in a dynamic way. So that problem, I think people may show more interest, also show some interest. Yeah. So that's a part I think is not shown in this demo, but I mean the problem has been solved. Yeah.
Yeah, and Zhezhen has like a lot of that experience too. This is the diagram that you see me sharing right now is in the doc, and that's kind of we tried to generalize kind of the architecture that ByteDance was imagining in a very somewhat generic but still hitting those issues. I think there's a number of core problems here that we'd like to align and share that we're trying to stay like as high level as possible to kind of give people that intro, but we're looking for folks who are interested in if you want that higher density, if you are using LoRA across multiple model servers already, or we know some people are using LoRA, but they're using merged adapters because it's still operationally expensive to go set up this sort of work. I think that's kind of where we're envisioning this proposal and the focus of a project like this around, hitting and solving some of these problems dynamically. What's the minimal intent API? What's the minimal OSS implementation? What's the minimal backend infrastructure that would work with the different model servers? And so maybe, yeah, if we want to tee up time next meeting, or I think that would be another, we can do that deep dive, Judge, and I think it'd be awesome if you could present and share some of your learnings around those key problems.
Yeah,
Yuan.
And another question
is,
about the. Sorry, yeah, go ahead.
Sorry, Dan, you can go ahead first.
Yeah, my question is about the ARM route, like a gateway API. So it seems like the currently we have the other. I'm actually thinking about the same thing. Like I think in my other proposal was using the same name, but it's like the use case is slightly different. So is this the idea is that this API will be like in future will be a standard like kind of gateway AI gateway API? I
think there's yeah. Go ahead. Who's going to jump in?
Sure. Yeah. I mean, so I think that to start and to allow us to iterate quickly, I'd love to see whatever this is start as a gateway API compatible route that actually exists outside of the gateway API project, so it can move faster. So kind of an experimental Kubernetes XK.io API group, kind of under working group serving, and collaboratively develop what exactly that looks like in the API service we want. And once we agree on what that does look like, I think then I would love to see it come into Gateway API. I just think there's a lot of details to work out first.
And I was actually going to say, Dan, like to your question, I don't actually know that this should be all possible use cases. And it might actually be better if we make the name more specialized or the group more specialized, like have multiple efforts based around a very concrete use case. So I actually think that the high level gateway is different in some respects. There is obviously overlap. It's totally not clear what that overlap would be. You know, I think we've been talking about Gateway for a long time internally. We were trying to find one use case that was both immediately valuable so that it could drive, we would want someone to be able to go deploy this and see a performance win or a sharing win operationally in production as fast as possible, right? Like we would want people who are doing LLM serving now to be like, I was going to go build LoRA infrastructure. I'm trying to grab, I'm either build it or grab it off the shelf. We wanted to kind of intersect for that very narrow use case. But we want to do it in a way that long-term, as Rob says, it would fit with other use cases. So if it's one API or two, or it should be decomposed into like 17 different API objects, what we wanted to pick an execution pattern that would let us solve for a problem, but then say for it to really, we know there'll be these other use cases and we think they're going to be important. As those develop, they're not bound, but then we can intersect them. And I think that's going to be hard. In the early days of Cube, we made a lot of guesses and we got some of them wrong. Ingress, we got wrong. And multiple people in the ecosystem, and it took 10 years to unwind it. We're still trying to unwind it. So that Rob and I have had a lot of discussions about, like, how can we A, benefit people doing LLM serving in production now, and B, not close the door for future additional functionality and composable functionality. So it's going to be a tightrope.
Yeah, I agree. Totally makes sense. Yeah, happy to have a separate discussion, how we can it's like how we can start this experiment with different use cases, and how in future we can merge. Probably we'll start from a different repo, and in future once we feel more comfortable, then we can merge onto the mainstream API. But yeah,
thank you.
I
we
can
have 3 minutes.
Maybe Rob, I can schedule a separate meeting with you, and I think Taran will be. I think he wants to chat about this as well. Maybe we can have a separate meeting on this.
Yeah, happy to chat.
Yeah, thank you.
We have 3 minutes for a quick round of questions. So, Kaisen, you're first.
Hi. Can you hear me?
Yes.
Yeah.
Go ahead.
Yeah, I think it's a good presentation, and I'm curious about for this project, is there any plan for support the auto scaling and multiplexing? Because I think this is similar to Ray. On Ray, I think each part is different. They have a different self replica, and I think in this project, I think every part has a different LoRA. So we cannot use a CPU or memory utilization to scale down a part. If it has only one LoRA instance on a specific part, if we scale it down, I think the request for that LoRA will be dropped. So I'm just curious, do we have a solution about the auto scaling?
I think one of the implicit things would be, today auto scaling, you mostly do it on a homogeneous pool. If you multiplex multiple use cases on the homogeneous pool, you need to have some aggregate metric that makes the best guess at what the capacity is. That's very similar to what the routing scheduling decision that Kaushik pointed out would have to do. So at least a thought process would be, and that's why Rob showed the latency objective on the LLM route, would be if you know the latency objective and you're making routing decisions based on that, you have a really strong signal when load exceeds not just capacity, but when you're stacking capacity, so instead of having fixed queue lengths, instead of having fixed batch sizes, you actually have more flexibility because some use cases like coding summary might be very latency sensitive. You might want to deliberately underload specific instances to get maximum latency or lowest possible latency. But if you get a spike in SQL use cases, the summary or the tweet summary might not be as critical. You can bump those. And so trying to have a central place that could build an aggregate view of demand, capacity, and objective could in theory let us generate a better autoscaling signal. That probably is a little bit further down the road, but I think that's what we're thinking of here is generating an aggregate scaling signal on the shared infrastructure based on that higher knowledge that Kaushik was talking about that the engine has that Cube just doesn't have today.
Okay, cool. Yeah,
thank you.
That's good. Thanks.
Ana Clara, you're next.
Hello, nice to meet you. I'm Anna. I'm a software engineer at Microsoft, and my team there deals with Kubernetes. I'm from AKS. I wanted to ask, this work looks really interesting, and I'm curious about more details. Do you have a research paper with more details of the experiments and the process, the findings that I could read? And by the way, sorry if you've already answered that previously. I might have missed it. Thank you.
The design doc. So the proposal linked in the design doc are linked in the serving agenda notes. And then in the design doc, there's a link to how the experiments were conducted. And this is just, the subset for the POC. I think, both ByteDance and Google are interested in, further experimentation that just aren't part of the POC right now.
Okay, thank you.
Thank you all, and we're 1 minute off, so I'll see you all in the next one.